Hi, everybody. So I just learned a lot of things from Debbie. So even though I'm not supposed to do this during the talk, I'm going to go stretch and a breathe. I'm going to put both of my feet on the floor and then we can get going. We'll see if the tips work for us. So I'm Maya. I worked at Luno and my talk is titled Getting Started with Jetpack Compose. And so just some background, Jetpack is a library for Android native development, and Compose is their new UI toolkit. So you might be thinking, well, I'm not an Android developer. And then my answer to that would be, well, maybe if you see how this works, maybe you want to become an Android developer. Or you may be in a different platform, and then this will be a nice way to introduce a way of using UI toolkits that might inspire you to do something different in your platform. So I'm hoping that there'll be something for everybody in here. Okay. All right, slides not going forward. Right, let me breathe and see if I can get the slides to work. View. No, there. Present. I'm getting good opportunity to practice Debbie's tips. So what and how am I going to run this workshop for you? First, I'm going to tell you what you'll need if you want to code alongside me. Then I'm going to give you a quick intro to Jetpack Compose, just to tell you what's new. And then I'm going to run through a code lab that's given by Google. It might take longer than the time, but we'll stop at the end of the time. And this will just show you how to get started quick and easily, and so that it will give you a space to explore. And then I also want to mention that in the Slack, if you can see on this picture, there's a Jetpack Compose track, and you can ask questions there. And I will be around for some days afterwards to answer some of your questions. So what you will need to try out the code lab is you need the Android Studio preview. Okay, and afterwards I'll also put the link to the slides, so you'll get all of these links. And then this is the code lab that I'm going to be following. And then I mentioned the Jetpack Compose Slack. And then there's an optional link that's also going to be part of the slides that I'll share. This is the pathway that gives you a whole lot of extra information about Jetpack Compose, some more videos, some more articles, and some more code labs. So you can either code with me, or you can just listen now, code later, and ask questions on Slack. Now let's dive into the intro. So we all have phones in our pockets, and there's apps running on the phone. And if you look at an app, whatever's on the screen needs to be fetched from somewhere. So either it's getting it from the internet somewhere, or it's getting it from on the phone. And then the app source code itself will build this UI based on this information. And then you, the user, can scroll open up and down and click on things. So I'm saying now that these things that are coming from the back end or from your phone, let's call that the state. So the state tells the UI what it should look like, and the user clicks things and scrolls, and let's call that events. So the events could change the state, right? You click on this cupcake image, and then maybe the cupcake picture comes up. So that's just to set the scene. And this is the same for whether you're doing iOS development, Android development, or any other development that involves a user interface. So this picture here is just what a typical Android architecture might look like. These squares are objects inside the code. So I've still got my state picture. The state puts the images on the screen. The URL possibly changes the state. And inside the Android app, what we would have is the activity is the thing that's going to show up on the screen. It might have a fragment. It might have another object that's remembering what the state is. It gets it from the internet or the repositories. It keeps the state inside this view model. And then in the old way of doing Android, we used to have an XML file. This is a different language. It's a different thing. You need to jump to a different screen. You tell in the XML, you say what you want your UI to look like. And this was kind of clunky because you would be using Java or Kotlin in this on these objects, and then you would have to jump into XML. And in addition, you'd need to wire it up so that you would be, the state that comes in over here would need to be displayed on the UI. So there would be some wiring code inside here, as well as if the user wanted to click, there was more wiring code to set up these clicks. So this new library from Android, the Jetpack Compose library, what it will do is it will replace this layout part with the Jetpack Compose library. And this is in Kotlin. This new library is in Kotlin. So you don't need to jump to another language. It's the same language as all of this if you were using Kotlin in the first place. Okay, so this is just a bit of a deep dive of how we used to do things in Android and how the new Compose way of doing things in. Before in Android, when your activity, and I showed you the activity over here, this activity or fragment, when that started up, what would happen is it would read all of these XML files, it would build a whole tree of structures of everything that's in your UI, all the buttons, all the views, all the pictures. You as a coder would have to go and find the right view using find view by ID. Typically, there are other techniques, but one of them would be find view by ID. You would look at what's in your state. You would set, there it's setting a text string on this view, and this code inside the fragment could get really messy, really easy. You could, if you just wanted to change a color and a picture, you might have two different places, or you might change something in one place or another place. And this could actually lead to quite a lot of bugs because these views might not be all in the same state at the same time. You would also have to set your click handlers to handle your user actions. So what Jetpack and Google have done is they've replaced this mechanism with nested functions. So they are just function calls, simple function calls, and one function calls other nested function calls. These function calls you can reuse, and what you do is at the top of the function, you say that this is a compose function by saying @composable, and then you just nest the functions. It's all written in Kotlin, and then because of this annotation, the system in the background will decide when and where and how to redraw the screen. So all you need to do, you just have to say what you want on the screen with these composable functions, and then the system will recompose them. The other thing is there's a known and fixed way of getting the state into these functions. You can pass them in by the parameters of the functions, and you also pass in the interaction handlers, which means that these functions themselves don't need to know anything about the outside world. They get everything passed into them, and they have everything they need to be able to show the state correctly on the screen. Okay. So you can see this is quite different. This is like XML and objects, and this is nested functions. And so that means we have to think a little bit differently when we are using Compose. So Compose thinking, some changes. So let me just explain to you how the state would come. So this oval is a function. It's a composable function. The state comes into it. The nested functions call other nested functions. If I have a view down here somewhere in my UI that needs a cupcake, the cupcake comes in from the state and gets passed all the way through here. If there's an event, the user wants to click on a button, the event handler would have come in from the top, and when this button gets clicked, it just calls the event handler out of the top. So this is a slight different way of thinking about it, which means we're not messing with the state. We're not necessarily messing with the state when you click the button over here. So everything's in Kotlin. The functions are nested. They're declarative, which means you just say what you want, and then the recompose mechanism will decide how it's going to draw. And the other thing is we need to write these functions to have no side effects. What we want to do here is that every single time you call a function, it must behave the same way. It mustn't have something that was set inside here that makes this another color. If I pass in the cupcake's going to be shown over here. So we have no side effects on these functions. One of the reasons why this is important is it means that you can test a subunit properly by passing in the things that you need to make the little view or the composable function do the UI effectively. The other reason why you don't want side effects is because we've got this recomposition. And so underlying under the hood, the system is going to recompose your views by calling these functions again. And this recomposition is actually pretty optimized so that it's quick to show the UI. And this means that this recomposition process has the right to call these functions in possibly any order that it thinks is optimized. So that means you don't necessarily know if it's going to call these pieces or these pieces first. It might even call some of them in parallel. It might skip things that have already been set up and that there weren't any changes. It might decide to cancel things because the user left the screen. And also it might call these things very frequently. If it's trying to draw some animation frames, it might call these things very quickly. So that is one of the reasons why you don't want your functions to have any side effects. Okay, that was a lot of squares and blobs and theory. I think let's just not go to questions. Let's jump into the code. So what I'm going to do now is I'm going to follow this codelab. So it's at that link, and we'll paste the links into Slack. The before you begin was just saying that you needed Android Studio, the latest version. Then starting a new Compose project, what they're saying you should do here is you should open Android Studio, click on create a new project. So this means that even if you haven't used any Android Studio things before, or you haven't done any Android, you can actually try this out. You can run Android Studio if you've got it from the previous link. You click on create a new project, and then you choose empty compose activity. So I'm just going to jump to the next screen. So here I have, this is very small, don't worry, it's going to be better. It's going to be bigger, quick. What I wanted to show you is that this user interface doesn't necessarily look like what that codelab looks like, but all you need to do is click that new project and you'll get the same screen. But I did actually make one for us. So I'm going to load that up, and I'm going to go into appearance presentation mode, and it should come up big for us. Okay, excellent. So now let's go back to the codelab. Just want to reorganize something here so this is easier for me. There. So the next step in the codelab after you've created this project is to start looking at the code. There are other things about build things, but I'm not going to look at that now. I'm going to just jump in straight into the code. So the first example that they've given us here is a greeting composable. You can see it's just a function. It's got this @composable, and it takes a name, and inside is a text. So let's just go over here. So here I have, this is what the codelab generated for us. It's a composable function. It's a function which is a Kotlin function. It's a greeting, and there's a text. Now, if I click on here in Android Studio, you'll see that it tells me what that is. Text. Text is a high-level element that displays text and provides semantic accessibility, blah, 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 blah. So this text is part of the library from Compose, and all of the things that you expect in a UI library are there. There are text fields, there are buttons, there are all sorts of things that you can use. And so the next thing I want to show you here is that if you have this composable and you want to see what it looks like, in the olden days, we'd have to run it on an emulator. But if you're in Compose, you can actually make a preview by doing this at preview. And then it will show you, you can call the greeting by making a composable preview function. So this is very small. You can't see this here, but if I zoom in, you'll see here, okay, the background's dark. We're going to fix that in the next step. But you can actually see that this is the default preview that we've got over here, and that it's actually showing me what my composable is doing because I'm passing in Android. And if I change this to Maya, and I rebuild, it's rebuilding, and hopefully rebuilding, change computer. It should show Maya here. Okay, we'll let that do that in the background, and let's just go back a bit here and see what else is in this codelab. This is lots of stuff for you to read, but what I want to show you here is how to hook in the Compose into your activity. So if I'm scrolling up here, we'll see this is the main activity of your app. This would look familiar to anyone who's done any Android coding. And there's an onCreate method, which is the method that starts up the activity. And over here, here's a new thing called setContent. This creates the environment in which you can call a composable. And we have our first composable being called here. Now, this is an interesting thing, this IWD Basics Compose theme. What this does is it sets the theme for the screen from our theme. And a theme, interestingly enough, in Compose, if I roll over it here, you can see that all of your theming is also just another composable function. Okay, so let's see what the codelab says next. So typically, if you were doing this on your own, you could just go through these steps. If you needed more information, you see there, they're talking about the codelab theme. So the things that I'm telling you are in here as well. And so there is the text preview. We spoke about the text preview, and I think we can go to the next step. Next. Okay, so now they spoke about the declarative UI. So we spoke about the declarative UI as well. And that just means that you say what you want. You don't have to tell it exactly how. So what they're doing here is they're saying, okay, we have a greeting with a text, but we want to change the background color. So I'm just going to cut and paste this code. I'm going to drop it in here. My greeting, we want a surface color. So you can see what I'm doing here now. This is a composable function, and I'm calling another one in it and another one inside it. So these are the nested composable functions. I see this is red because it doesn't have a color. I'm going Alt Enter, import. Okay, now when you import, what you need to do is you need to make sure you're picking the compose element. And now, hopefully, if I build and refresh, we'll see some yellow background coming up here. Great. So you can see, again, I want to stress here that I didn't need to run it on the emulator. You can run it on the emulator by pressing that button, but you don't need to run the emulator. You can actually get really quick feedback on your screen like this. Okay, so there they're saying refresh the preview. We just did that. Hello, Android. Okay, so now they're talking about modifiers. So while I copied this, I'm just going to copy this piece of code here. Right. So a modifier is something that you pass into your composable that lets you modify how that UI is drawn. So what we've got here, we've got this text, but it's super cramped. We actually want a bit of padding here. So if I go into this text and I go Control P, we can see there's a lot of potential things that you can add as parameters, and one of them is a modifier. And a modifier has lots of things that you can set. You can set font size, you can set all sorts of things. But for now, we're just going to set, we need a comma, modifier. All right, we need to make another import. Again, checking for the compose import, padding, import, DP, import. Right, now build and refresh. And we should get some padding. Yes, we got some padding. Excellent. So build and refresh, padding. Okay, so now they're talking about reusability. Okay, we can do that. So the idea with Compose is that, yes, I've got this greeting, but maybe I want to call this greeting in another place. Or maybe I want to set it up so that my screen that this is my app screen, so that this app screen is just for this app screen, and that I can reuse these functions. So instead of having an XML with different XMLs that are being reused, I can recall these functions and use them in different places. So what they want me to do here is they want me to make a composable function called my app. Okay, I'm going to cut and paste that. Okay, so another thing that's interesting here is, look, this class is at the top level. And these functions that I'm adding, they are just top level Kotlin functions. Oops, no, that was awful. So that means you can put these functions in different files. You don't need to have them inside of your actual class that is the activity. Let's see, is that better? Yes. Okay. So this is wrong because I've got a different theme. Let's take that theme. Okay. Right, that's better. So this is a new composable function. So what we're saying here is that I want my app to look like this, and I want you to use that theme. And that's what I want over here. Let's see, and they're saying now the preview will be my app. I'll call my app in the preview, and we'll call my app in the content. So what we'll do is we'll replace this with my app, and we'll replace this with my preview. So I think what the good idea to be here is that you would have a preview for your activity so that you can see what's happening in your activity. You might have this greeting in a different place so that you can use it in other screens. And then you would have this composable that's just for your app. Build and refresh. And it should still look the same. Okay, it is in fact looking the same. So there we are. Container functions. Okay, we can do container functions. So they're changing this my app composable, and what they're doing over here, you can see this piece over here. So what this parameter means, it means that my app can take another composable function. And this is the way that you build it such that you can do nested functions. So let's just cut that piece of code in there. I think I need the whole function like that. I'm just checking the time because I'm going to have to stop at the point. Right. This is a different one. IWD. Post in. There we are. Okay. So this my app will take that. And then we're changing it over here. The set content becomes my app greeting. Okay, so now what you see here is you see these curly braces on the outside and you don't see the parameters. The reason that that's like that is because there's a Kotlin convention that if this last parameter is a function call, you can move it outside. You can move the parameter to be outside the braces and just call the curly braces. If you need to search more about this, it is in the codelab. They explain how that works. This is the same over here. And I'm building and I'm refreshing, and it should work. Okay. All right, so we've got this there. The other good thing you can do with these composable functions, you don't need to just call them once. So what we're doing over here now is we're nesting these greetings inside a column. Now, a column is a composable function that will let us put these functions, these views, one below the other, and there's a divider in between. So I'm going to see, did they change? Maybe I got the code wrong a bit. Greeting. Okay, she's making a new screen content. We'll do that. So we're making new screen content over here. Right, so let's have a look at this column. I need to import column. I need to import a divider. Again, checking to make sure I've got the compose one. Right, so if I hover over column, it should tell me things. Okay, I'm not getting the help. Never mind. So what a column will effectively do is it will draw this one and then this one and then this one below itself. So I'm going to change it to this. I'm going to call it, let's call it in the preview first. Let's see what they're doing here. Yes. Oops. I'll call it over here. So let's rebuild and refresh and see what that looks like. Aha. So what we're seeing here now is that because we're calling this composable function my screen content, it is in fact drawing one greeting, giving me a divider, and then drawing another greeting. Okay. Okay, so that's that piece. Okay, you know what I need to do? I need to just make sure that I am actually getting the screen content and putting it in my app. Otherwise, if we ever run it on the phone, it's not going to work correctly. Okay, so there's our preview. You can also, of course, have a for loop. So let's do that. Let's change the screen content to just have a for loop. And we'll do that in here. Screen content. Okay, it's not going to compile because these things need parameters here. Let's see. It's got a default parameter. Okay, the reason that this would work is because this has a default parameter. Let's build and refresh. And we should see hello Android, hello there. It's because we have two of these. I could add another one over here and say Maya, refresh. And it should give us 3 now. It does in fact give us 3. So you can see that you can make these composable functions very dynamic with whatever you add. And the great thing about this is all Kotlin code and you don't need to go into the XML. Okay, I think we can do one more step in the code lab. I'm just checking the time. We're not going to spend 42 minutes on this. I think I'll start the next step. Actually, no, let's not do one more step. What I'm going to do now is what's interesting is I'm going to run this on an emulator by pressing that button. That's not working. We'll say view, appearance, exit presentation mode. Let's just run it on an emulator just to show you that you're getting exactly what we added into our activity in the emulator. Okay, 0 errors. Could not be installed. Retry. It was too quick, maybe. So this is a good thing to see, that starting up the emulator takes way, way longer than seeing what the Compose looks like in a preview. And here you can see exactly what we have over here. We have inside our app. Okay. I just want to go back to the slides for a moment, because on my slides, this would have been the question section, and in Bevy, that would have been easier. But what I do want to just tell you is that there are resources. The slides will have a link to the official docs. There's a whole GitHub repo of example apps, and there's a very good overview video by Nick, which I will also link in my slides. So that everybody can have a look at that, which goes into much more depth. Now, I still actually have a bit of time, so maybe let's see what the state looks like. So let's look at the state. So now state in Compose, we had a whole long discussion about the state. I'm just going to have a look here. And what they're doing over here, okay. So they're going to make a composable function, which is a counter. So now I know I told you that the state is always passed in, but there is a way to make a state that's just local. And the reason you would want that is if you have something like this counter function. I'm going to put a counter function in here. I'll put the counter function in here. Just pulling in import. I want the compose one text. Okay. Sometimes you have something that's just like this counter function that remembers things locally, and it doesn't need to go outside of this composable. You don't want to share that outside of it, but you still need to tell the compose hierarchy that this is something that needs to be kept in state. the Compose library has given us a way to remember that. That means that in that recomposition loop that I told you about, where it actually changes things and can decide when things get called, it will do it correctly for a state that's annotated like this. So we're telling the compose recompose function that it's remember, and there you can see remember the value produced by, and then there's a mutable state of a value. Now this button, there you can see the action is being passed into the button. So the button doesn't have any way to change the action. There you're setting the onClick handler. And what the onClick handler must do is it must increment the count value. And then the text on the button changes and says, I've been clicked so many times. So we have this new counter, which is this new composable function. So this would be like a special button. So this is a button that can also count. Let's just go over here and paste it into the code. Where did they put it in? They put it right at the bottom after the for loop. So I'm going to cut and paste that. And then go back here. So greeting divider for loop. So we want all of these, the for loop with all of these texts. And then we want the little counter to go in after that. And then bold and refresh. And we should get a little button appearing at the bottom here. There we are. Okay, let's just zoom in a little bit. So here's our button. Now I want to show you another cool thing. So this is just the way things will look visually, but if you clicked on this, it wouldn't let you click it. But you see this icon over here, that's the Start Interactive Mode icon. If I click that, it starts it up in interactive mode. And now you can actually click this button and you can see the counter incrementing over here. So this is really useful if you're building small composable things and you need to be able to interact with them and see how they work. And then if you want to go back to the other mode, just go stop interactive mode and then you're back into the other mode. Okay, now I think I might actually have run out of time. I think I'm going to jump back to the slides and go into questions. And then Vuyo can take questions if there are. I'm not seeing.
Hello.
I'm going to stop
sharing. Guys, do you have any questions for Maya? Please type it in the chat. Vuyo's just stepped out for a second. Thanks for that, Maya. That was really great. I am very fond of Jetpack Compose. It's an amazing technology, and I think I've just been seeing these amazing, like for me, one of the most amazing ones are the animations that are possible with Jetpack Compose. I've been seeing a lot of interesting clocks and just
folding cards, doing things like that.
Yes, amazing animations. So some of the comments that we've been having is sharp and saying very informative and giving you a lot of shout outs. So Tawaka is asking, what is the latest version of Android needed for Compose?
I think 21, Pam. I don't know. Can you remember?
So you actually, it's not bundled with the operating system. So you actually don't need to have a certain API that I know of. It's not bundled with the operating system. So there's no version of Android that you need.
What you do need, though, is you need the latest Kotlin compiler, because that at composable annotation, what it actually does underneath, it secretly puts extra code into your function so that it will display on the UI. And only the latest version of the Compose compiler can actually do that. So it's more important to have the latest version of the compiler on Android Studio than it is to have the version of Android that it runs on.
Exactly. So Tina Window asks, I see Java is being sidelined these days, so no Compose is available for Java.
No. But Compose has quite a good interoperability story. So what that means is you can have a Java app, and then you can just, because you can have Kotlin and Java in the same app, you can make a screen that's Kotlin, and you can have Compose in the Kotlin screen, or you can make, if you have a Kotlin screen, you can also have old XML and put a Compose view inside your old XML, or you can have a Compose screen and put your old XML custom views inside a Compose view if you need to. So there are all sorts of ways that you can, in small pieces, pull Compose and or Kotlin into your Java app. So all is not lost.
So Sean has just corrected us. Compose is backward compatible to API 21. Thank you for that.
Yeah. Cool.
Right. We have another question, which you may or may not want to answer. Is Luna using anything from Jetpack?
Yes. Yeah, we haven't got Compose in our app yet, but we do use, I mean, the Jetpack libraries are so cool. There are all sorts of other Jetpack libraries. And so, yes, we do use, we use architecture components, and we use some Jetpack libraries, yeah. But not Compose yet, no.
Although, I mean, with Compose, you can very incrementally start using, you can start with one screen and, you know, just convert your XML layout, or maybe just new screens to Compose.
Yeah.
You don't have to do your whole app all at one,
No.
all in one go.
You don't need to do your whole app, but you do need to make sure that your app builds with the latest versions of the plugins and the compilers. So that's typically what, if you said I wanted to put Compose inside my app, that's where I would start. I would just make sure that all of my builds are up to date and everything works and compiles up to date with the latest tools, and then start in a small, find the about screen, the help screen, one small screen, one small info screen, and then change that to use Compose.
Okay, it seems like, and Danae says you're killing at live coding. Thank you, Danae.
Thank you.
Very
nice. All the breathing exercises, see?
Breathing. It's not the million years of experience of live coding, of coding. It's obviously the breathing.
And both feet on the floor.
And both feet on the floor, yeah.